Coral reefs are among the most vibrant and valuable ecosystems on Earth. Though they cover less than 1% of the ocean floor, they host around a quarter of all marine life and support millions of people worldwide. From food and income to coastal protection and tourism, their importance extends far beyond the sea. Yet, these living structures, built over centuries by tiny coral polyps, are now under serious threat. Stony corals, the architects of reefs, are colonies of small animals that secrete calcium carbonate skeletons. They live in a close partnership with microscopic algae called zooxanthellae, which provide them with most of their energy through photosynthesis. This relationship explains why reefs thrive only in warm, clear, sunlit waters. Beyond their beauty, reefs play a vital role in human life. They support fisheries, safeguard coastlines from erosion and storms, draw millions of tourists each year, and hold deep cultural significance for coastal communities. Their loss would not only be an ecological tragedy but a profound socio-economic blow. The greatest threat to reefs today is rising sea temperature. Even a sustained increase of just 1 degree Celsius can cause corals to eject their algae partners, a process known as bleaching. If high temperatures persist, corals starve and die. Added to this is ocean acidification, which weakens coral skeletons by reducing the availability of carbonate ions. Local human activities make matters worse. Overfishing, coastal construction, and polluted runoff all reduce reef resilience. These pressures combine, leaving corals less able to recover from the increasingly frequent marine heatwaves driven by climate change. Since 2023, scientists have observed one of the most extensive bleaching events ever recorded.
We've seen an unprecedented coral bleaching event hit 80% of the world's low-latitude reefs. So that kind of confirmed our collective deduction that the tipping point, the sort of temperature tipping point for corals was probably below 1.5 degrees C.
What happens with coral bleaching is that this symbiosis, this relationship between the animal and the algae, becomes disrupted. So the algae no longer stays within the tissues of the coral, leaving it without its color, leaving it weaker and vulnerable because it doesn't receive the nutrients and the food sources that the algae provides for the coral.
The U.S. National Oceanic and Atmospheric Administration confirmed that heat stress has affected the majority of the world's reefs, including Australia's Great Barrier Reef. By 2025, researchers warned that coral ecosystems may be nearing, or have already crossed, a critical tipping point, where repeated bleaching and mortality become the norm rather than the exception. This global trend reveals that coral loss is no longer isolated or temporary. It is a sign that the ocean itself is changing faster than many species can adapt. When reefs die, the consequences reach far beyond the sea. Coastal fisheries collapse as fish lose their breeding and feeding grounds. Tourism suffers, affecting local economies that depend on visitors. Even the physical structure of reefs, natural breakwaters that soften the impact of waves, begins to crumble, exposing shorelines to greater damage from storms. Biodiversity loss also means losing potential sources of medicine and new scientific discoveries. The hardest hit are small island nations and developing coastal states that rely heavily on reef ecosystems for food and livelihoods. Despite the scale of the challenge, hope remains. Scientists and conservationists have identified a path to protect what's left and restore what's lost. Reducing global greenhouse gas emissions is the single most important step to secure the future of coral reefs. No local action can compensate for unchecked climate change. At the same time, improving local management through better fishing practices, pollution control, and marine protected areas can strengthen reefs' natural resilience. Healthier reefs are better able to withstand heat stress and recover after bleaching events. Across the tropics, scientists are also experimenting with coral nurseries, microfragmentation to speed up coral growth, and selective breeding to produce heat-tolerant corals. These approaches show promise but remain costly and labor-intensive. They can complement, not replace, climate action. Restoration also raises complex questions. Should we prioritize fast-growing species to rebuild reefs quickly, or rare corals vital for balance? Should humans actively guide coral evolution through genetic selection? Such choices require transparency, local participation, and respect for traditional knowledge, ensuring that efforts are fair and grounded in the communities most affected. Saving coral reefs ultimately requires action at every level. Governments must meet emissions targets, industries must reduce pollution, and individuals can help by supporting sustainable seafood, responsible tourism, and conservation initiatives. Coral reefs have survived natural changes for millions of years, but the current pace of warming is unprecedented. Their fate now lies in human hands. With urgency, innovation, and cooperation, we can still preserve these irreplaceable rainforests of the sea, not only for their beauty, but for the life and protection they offer to the world.